Okay, so the Krebs cycle or citric acid cycle. Again, in high school, you probably don't need to know the names and enzymes and the structures, but again, it is a good idea to know them simply because it gives you a much deeper understanding of the cycle, as well as you're going to learn it. You're going to be expected to know it later on in university, first or second year. So might as well get started. Okay. So normally what I do, again, very much like the glycolysis, I try to remember the steps, what happens to it, and then in terms of the names, I just try to make sense of the names of the enzymes so that helps me remember. Okay? So I started off with the one that's acetyl-CoA joining the oxaloacetate for carbon. That will give me citrate. Okay, from citrate, it gives me isocitrate. It's just things being reorganized, so it's iso, like an isomer of citrate. And then from isocitrate, it goes to alpha ketoglutarate. From okay, so from iso, it goes to keto, and then from keto to succinyl CoA. Succinyl CoA becomes just succinate. I got rid of the CoA along the way, and then succinate, it goes from fumarate, malate, and O. So there are a couple ways for you to memorize it. You can remember it. For me, after succinate, I just remember SFMO. SFMO. Just the first letter. Okay? So that's how I remember it. Now, in terms of enzymes, okay, again, just straight up names is harder for me to memorize. I do try to remember, try to make a story out of it so that I can remember this better. So first step, it will be making a citrate. So citrate synthetase. Okay, it will be synthesizing a citrate. Okay, and then the steps from citrate to isocitrate is not isocitrate, whatever, but it's a aconitase. Aconitase. Not sure why it's aconitase, but that's really just I just remembered the name citrate and aconitase. Now the second part. Now I have isocitrate. Now this is a part where I'm going to lose hydrogen. Keep in mind you're going to be losing hydrogen quite a bit along with electrons in the Krebs cycle a fair bit. So you'll do it once, twice, 1, 2, 3, 4. Every time you lose hydrogen, you have a dehydrogenase. Okay? Dehydrogenase, 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 dehydrogenase. So, in this case, after the isocitrate, that's when I start to remember. It's like, oh yeah, that's where I start losing those electrons and hydrogen. So, isocitrate dehydrogenase, and I'm going to lose the electrons again. So, alpha ketoglutarase dehydrogenase. Now I know that after alpha ketoglutarate, I have a succinyl CoA. So I know that from succinyl CoA to go to succinate, I need to get rid of the CoA. So it's succinyl CoA. Now it's not quite synthesis, it's synthetase. I'm not quite sure why there's a little different, but that's how I used to remember it. It's not synthesis, but it's opposite of that, getting rid of the CoA part. Now I have succinate. I know I'm losing hydrogen and electrons again, so it's succinate dehydrogenase. Give me fumarate. Now fumarate, go from fumarate to malate. I know that the enzyme works on the fumarate, so it's fumarase works on fumarate. Give me malate. From malate to go from oxaloacetate, I will lose hydrogen again, so it is malate dehydrogenase. Here I lost electron and hydrogen again. Goes from this one, oxaloacetate. At that point, when I see another acetyl-CoA, it will form and give me citric acid or citrate. So that's kind of how I use to help me remember the citric acid cycle. again, just to make sense and remember the steps, what's going on. It will help me remember the enzyme's name as well as all the steps in between. Okay.